Air-to-water technologies can provide water and sustainable, green growth to the arid areas. Welcome back to our channel, where we explore fascinating technologies that are changing the world for the better. Today, we have something truly remarkable to discuss: air-to-water technologies. Yes, you heard it right. We're talking about creating water from air moisture and humidity. So, let's dive right in and explore this incredible innovation. Before we jump into the specifics of air-to-water technologies, let's quickly recap the water cycle. The water cycle is nature's way of distributing and recycling water on our planet. It involves evaporation, condensation, and precipitation. But what if we could harness this natural process and create water on demand, regardless of the location? That's where air-to-water technologies come in. These innovative systems leverage atmospheric moisture and humidity to produce clean, drinkable water. How does it work? Well, it's a combination of cutting-edge science and engineering. Air-to-water machines use a process called condensation to extract water from the air. They pull in air through an intake system and pass it through a series of filters to remove dust, particles, and pollutants. Then, the moist air is cooled using refrigeration or desiccant technologies. As the air cools, water vapor begins to condense into liquid form, just like droplets forming on a cold glass on a humid day. These droplets are collected and stored in a reservoir, where they undergo additional filtration and purification processes. To give you a better understanding, I have this air-to-water demonstration unit here. As the air passes through the machine, you can see water droplets forming and being collected in this reservoir. And here it is, pure, clean drinking water, generated right from the air around us. It's incredible how technology can turn an abundant resource like air into a vital necessity like water, especially in areas where access to clean water is limited. Air-to-water technologies have a wide range of applications. They can be used in disaster relief efforts, providing emergency drinking water in areas affected by natural disasters. They are also valuable in arid regions where traditional water sources are scarce or contaminated. Additionally, air-to-water machines can be installed in homes, offices, or even integrated into larger-scale infrastructure to ensure a sustainable and independent water supply. The potential impact on global water security is enormous. But what about the energy requirements of air-to-water technologies? Are they sustainable? While air-to-water technologies do require energy for the cooling and filtration processes, advancements in energy-efficient systems and renewable energy sources can help minimize their environmental footprint. Additionally, energy requirements can be offset by a reduced reliance on transporting water over long distances or treating contaminated water sources. Air-to-water technologies utilize innovative systems to extract water from the atmosphere by harnessing moisture and humidity. Here's a detailed explanation of the process. Intake and filtration. The air-to-water machine draws in ambient air through an intake system. Before the air enters the water generation process, it passes through a series of filters. These filters remove dust, particles, and pollutants, ensuring that the water produced is clean and safe for consumption. Cooling the air. Once the air is filtered, it undergoes a cooling process. There are two primary methods for cooling the air: refrigeration and desiccant technologies. Refrigeration. In this method, the air is cooled using refrigeration principles. The air passes over a refrigerated coil, which causes its temperature to drop. As the air cools, its capacity to hold moisture decreases, leading to condensation. Desiccant. In desiccant-based systems, the air is passed through a material called a desiccant, which absorbs moisture from the air. The desiccant is then regenerated, releasing the collected moisture as water vapor. Condensation. As the air cools, the moisture in the air begins to condense, similar to how droplets form on a cold surface on a humid day. The condensed water vapor turns into liquid form and is collected for further processing. Water collection and storage. The droplets of condensed water are collected in a reservoir or storage tank within the air-to-water machine. This reservoir is designed to prevent contamination and maintain water quality. Filtration and purification. Once collected, the water undergoes additional filtration and purification processes to ensure its quality. These processes may include carbon filtration, UV sterilization, reverse osmosis, or other advanced treatment methods to remove impurities, bacteria, and other contaminants. Distribution and usage. The purified water is then ready for distribution and use. It can be dispensed through taps or outlets connected to the air-to-water machine, allowing easy access to clean drinking water. It's important to note that the efficiency and capacity of air-to-water technologies vary depending on factors such as ambient humidity levels, temperature, and the specific design and capabilities of the system. Some advanced systems are designed to optimize water production even in low humidity environments. Air-to-water technologies offer numerous advantages, particularly in regions facing water scarcity or contamination. They provide a decentralized and sustainable solution for obtaining safe drinking water, reducing the reliance on traditional water sources and the need for long-distance water transportation. Furthermore, these technologies can contribute to disaster relief efforts and improve water security in remote or arid areas.